Hello everyone, I am Sir Jan. I am your mathematics teacher for today. Welcome to another mathematics tutorial. In this video, I am going to teach you how to factor using GCF or the greatest common factor. This topic is so important in grade 8 and grade 9 as we build your foundation for future topics like solving quadratic equations and factoring polynomials. Since most of the learners have difficulties in factoring, I made this video hoping that it will help you to achieve your goals and be confident in your mathematics skills. Here are the objectives of our lesson. Define greatest common factor in factoring. Find the greatest common factor of two or more expressions. And factor the greatest common factor from a polynomial. Let's begin this discussion by the diagram below. 6 times 7 equals 42. 2x times quantity x plus 2 equals 2x squared plus 4x. This process is called multiplication, or we multiply two numbers called as factors and it yields to a product. From factors to product. In this video, we are going to reverse the process, meaning from product to factors. This process is called factoring. Let's define factor. A factor is a number or algebraic expression that divides another number or expression evenly. For example, 6 is a factor of 42. Why? Because if we divide 42 by 6, that is 42 divided by 6, it will give us 7. In this expression, 2x is a factor of 2x squared plus 4x. Why? Because if we divide 2x squared plus 4x by 2x, it will give us x plus 2. Now let us define the greatest common factor. The greatest common factor, or the GCF of two or more numbers, is the greatest number that is a factor of each number. Meaning to say, in order for us to get the GCF, there must be two or more numbers given, and we will find the greatest number that is the factor of each number. Let's have an example number 1. Find the GCF of 18 and 30. There are two methods in finding the GCF of two or more numbers. The method number 1 is to list all the factors of each number. Step 1. Listing or list all the factors of each number. The factors of 18 and the factors of 30. Factors of 18 are 1, 2, 3, 6, and 18. So there are 5 factors of 18. Factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. There are 8 factors of 30. Step number 2. Identify the common factors. Factors of 18 and factors of 30. In order to identify the common factor, let's compare the factor of each number. Let's ask and circle the common factors. We have 1, 2, 3, and 6. There are 4 common factors of 18 and 30. Step 3. Find the GCF, or the greatest common factor. As what we defined earlier, the greatest common factor is the greatest common factor of 18 and 30. So by looking at the common factors, we have 6 as the greatest common factor. that is GCF of 18 and 30, is equal to 6. Now we can state that 18 and 30 is a multiples of 6. So 18 is equal to 6 times 3 and 30 is equal to 6 times 5. Let's have example number 2. Find the GCF of 36 and 54. Again, for step 1 rather, list all the factors of each number. So factors of 36 are 1, 2, 4, 6, 9, 12, 18, and 36. Factors of 54 are 1, 2, 3, 6, 9, 18, 27, and 54. For step 2, identify the common factors. Now let's encircle the common factors of 36 and 54. So we have 1, 2, 6, 9, and 18. Now it is now very easy to identify the GCF of the factors of 36 and 54. Step number 3, find the GCF. So the GCF of 36 and 54 is 18. Again, we can state that 36 and 54 are multiples of 18. So 36 equals 18 times 2 and 54 equals 18 times 3. Now let's go to the next example. Given the same problem, we will find the GCF using the prime factorization. Now what is a prime factorization? Let's define first what is a prime number. A prime numbers, they are numbers that have only two factors, 1 and themselves. The first 5 prime numbers are 2, 3, 5, 7, 11. As you see that these numbers, their factors are only 1 and themselves. By contrast, if it is more than 2 factors, like for example 4 has a factors of 4 times 1 and 2 times 2. Then they are called composite numbers. So any numbers that are not prime are called composite numbers, like 4, 6, 8, 10, and so on and so forth. Now let's find the GCF of 36 and 54 using the prime factorization method. Step 1. Write the factorization of each number. So we have here 36 and 54. Thirty-six has a factors of 6 times 6, and 54 has a factors of 9 and 6. We can still find the factors or prime factors of 6 as 3 times 2, 6 as 3 times 2, 9 as 3 times 3, and 6 as 3 times 2. Observe that these numbers 3, 2, 3, 2, 3, 3, 3, and 2 are all prime numbers. So we are able to get the prime factorization of each number. Now step 2. Identify the prime common factors. So for 36, the prime factors are 2 times 2 times 3 times 3. For 54, we have 2 times 3 times 3 times 3. Now let's encircle the prime common factors. The prime common factors are 2, 3, and 3. Step 3. Bring down the common factors. So the common factors, or the GCF, is 2 times 3 times 3. And let's multiply the common factors. GCF of 36 and 54 is 2 times 3 times 3 is equal to 18. So it yields to the same GCF from our previous example using the method 1. So this method is the prime factorization method. Let's have the next example. Find the GCF of 45 and 72 using the prime factorization. Step 1. Write the prime factorization of each number. For 45, the factors are 9 times 5. For 72, 18 times 4. Now we can still find the factors of 9. That is 3 times 3. 5 is considered as a prime number. For 18, we have 2 times 9. For 4, 2 times 2. 9 is not a prime number, so we can still find the factors of 9. So we have 3 times 3. So these numbers, 3, 3, 5, 2, 3, 3, 2, 2, are the prime factors of 45 and 72. Now let's go to step number 2. Identify the prime common factor. For 45, the prime factors are 3 times 3 times 5. For 72, the prime factors are 2 times 2 times 2 times 3 times 3. Now let's encircle the common factors. So we have here 3 and 3. For step number 3, bring down the common factors. So the common factors, or the GCF, is 3 times 3. Step number 4, multiply the common prime factors. We have GCF of 45 and 72 is equal to 3 times 3 equals 9. Then we can state 42 and 72 as multiples of 9, as 45 is equal to 9 times 5 and 72 is equals to 9 times 8. In the first examples, the GCF are constants, meaning to say all the examples that we did, their GCF are numbers. Now, in the next examples, we will get variables in the greatest common factors. Let's have an example. Find the greatest common factor of 27x squared and 18x cubed. We can use the method number 1 or method number 2 in this example. Let's have a solution. Factor each coefficient into primes and write variables with exponent in expanded form. That is, 27x squared is expanded as 3 times 3 times x times x. Notice that all of these numbers, 3, 3, and 3, are prime numbers. 18x cubed can be expanded into 2 times 3 times 3 times x times x times x. As you notice that the encircled numbers are the common factors between the two expressions. Bring down the common factors. So the common factors of the two expressions are 3 times 3 times x times x. And multiply the factors, or the GCF of 27x squared, 18x cubed is 3 times 3 is 9, and x times x is x squared. So therefore, the GCF of 27x squared and 18x cubed is 9x squared. Let's have another example. Find the greatest common factor of 21x cubed, 9x squared, and 15x. So we have three terms here. For 21x cubed, it can be expanded into 3 times 7 times x times x times x. 9x squared can be expanded into 3 times 3 times x times x. 15x is equal to 3 times 5 times x. Now, what are the common factors of the three terms? So let's encircle. So the common factors are 3 and x. Now let's bring down the common factors. So we have the GCF is equal to 3 times x. Multiplying these two expressions, we can now get the GCF, which is 3x. Now let us factor the GCF from a polynomial. One way to do this is by finding the GCF of all terms. In our previous diagram, 2x times quantity x plus 2 equals 2x squared plus 4x. These expressions here, 2x and x plus 2 are called factors, and 2x squared plus 4x are called product. Now we're going to reverse the process that is called factoring. So what do you mean by the distributive property? If a, b, c are real numbers, then a times quantity b plus c equals ab plus ac. So this is how the process of multiplying two polynomials. We have a monomial times a binomial. Now we can reverse this process. So we have ab plus ac is equal to a times quantity b plus c. So this process here is what we're going to do. Let's have an example. How to factor the GCF from a polynomial? Example number 1. Factor 6x plus 18. We have now the solution. Step 1. Find the GCF of all the terms of the polynomial. So the terms of these polynomials are 6x and 18. Find the GCF of 6x and 18. So 6x can be expanded into 2 times 3 times x. 18 can be expanded into 2 times 3 times 3. So the common factors between these two is 2 and 3. So the GCF of 6x and 18 is 2 times 3, which is 6. Step number 2. Rewrite each term as the product using the GCF. 6x equals 6 times x. 18 is equal to 6 times 3. Therefore, 6x plus 18 can be translated into 6 times x plus 6 times 3. Notice that each term has a common number, which is 6. Let's have step number 3. Factor the expression using the reverse distributive property. Using the reverse distributive property that we discussed earlier, 6 times quantity x plus 3. Step number 4. Check by multiplying the factors using the distributive property. Let's check if this factor 6 and x plus 3 is the factors of 6x plus 18. So 6 times quantity x plus 3. So let's distribute. 6 times x is 6x. 6 times 3 is 18. So we have 6x plus 18, which is correct. Therefore, the factor of 6x plus 18 is 6 times quantity x plus 3. Let's have another example. Now we'll factor the GCF from a trinomial. So in the previous example, that is a binomial. Let's have a trinomial. Example 1. Factor 4x squared plus 24x minus 28. Step number 1. Find the GCF of all the terms of the polynomial. We have 4x squared can be expanded into 2 times 2 times x. 24x is 2 times 2 times 2 times 3 times x. 28 is equal to 2 times 2 times 2 times 3. So the common factors of these three terms are 2 and 2. Step number 2, rewrite each term as the product using the GCF. So 4x squared is equal to 4 times x squared. 24 is equal to 4 times 6x. 28 is equal to 4 times 7. Therefore, 4x squared plus 24x minus 28 can be expanded into 4 times x squared plus 4 times 6x minus 4 times 7. Notice that 4 is the common number of these three terms. So, step number 3. Using the reverse distributive property, we can now factor 4 by taking it outside in the parentheses. So 4 times quantity x squared plus 6x minus 7. Well, let us check if this factor is correct. So 4 times x squared plus 6x minus 7 using the distributive property. We have 4 times x squared plus 4 times 6x minus 4 times 7. 4 times x squared is 4x squared. 4 times 6x is 24x. 4 times 7 is 28. So we have the correct factor. Practice makes perfect. So I prepare here practice test for you. You can comment below for your answer, or you can send me through my email. So these are practice number 1 and practice number 2. Okay. I also prepared self check for you to assess yourself. So direction, put a check to assess your skill on this lesson. I can apply the two methods finding the greatest common factor. If you're confidently put check with some help, no, I don't get it. Find the greatest common factor of two or more expression and factor the greatest common factor from a polynomial. You can comment below what was your assessment of yourself. Thank you so much, class, for listening in this video. I hope you enjoy and learn about our discussion. So for our next tutorial, I will discuss how to solve quadratic equations using extracting square roots, factoring, completing the square, and quadratic formula. Thank you so much and have a good day.